Okay, it's Roger, Mudfossil University, with a rare opportunity. We're going to be looking over some pictures from Micheal Tellinger, who graciously allowed me to examine the things that he's looking at and to try to make an assessment of what I think they might be, and then he can take it from there. But hopefully this will lead to some acceptance of mud fossils. People will see it, because I don't have a whole lot of exposure, and Micheal does, and I appreciate this opportunity, and I'm hoping he will be able to get people to understand this is a reality and something that should be started to examine. And this could be a huge thing for everyone to be able to really look at this for the reality of it, because this is not just a monkey bone and a curiosity and just something for people to, ooh, this is great, you know. Well, they're going to think that, but you think a little deeper. And we'll go there a little bit here and there with it, Micheal. So, you know, bear with me. I'm not just going to say this is this and this is that, because there's a little more to it than that. So I just want you to appreciate that I'm having this opportunity. Everybody needs to understand this, and the people that come to my site will see this, and I hope they'll see it at your site too. So anyway, here we go. Let's see what you got, buddy. Okay, that one there, I believe, is again part of a tendon assembly, or I mean, it has that appearance to me, and I'll show you why I say that. Let me show you what a tendon ball looks like in the external, structural part of it. Okay, Micheal, I think what you have is something similar to this, only a piece broken off of that. And these are the stone balls, and what happens is there's an external, well, let me show you some other shots, but there's an external shield around it, which has this type of structural component within it. It separates these off into blocks, and then inside there's another spheres, and let me show you that. See, here's another one that's even more eroded. This came from, I think it was from Lee Simpson. We have a ton of people all around the world that send me all kinds of things. Very, very, very gracious. Nobody's doing it for any money. We're just doing it to try to, see what our reality is. And I think this is what you're looking at there. And there's so many things that look like how could this possibly be from nature? But every rock that you pick up, my friend, is previously a living creature's body part. I mean, it's just a fact that I can't find any that aren't. All right, here he goes. You see, it's highly dependent upon the conditions that the thing finds itself in when it begins to get preserved, and how long it stays in wet conditions. Your stuff is extremely dry, and I will show you what I'm going to say is these tendon balls that have been so dry in your area that they don't fully resemble these, but similar. You can see the same structure. Anyway, and the funny thing is, these have an internal core, and they made these plates in China, I think, out of these balls that are so fabulous, and nobody can figure out how they made them, but I think they made them from these. Hold on, I'll show you. All right, this is a better a shot of it. This is just a completely round core that has literally sand inside of it, as far as I could determine, and then it has this circle around it, which is just another ball, and then this is what is called chert, or flint, really, is this kind of stuff. I'm almost sure. These are things that should be tested, and if you have a guy, you said you have somebody who can do these testing, these are the kind of things that, I'm almost sure what I'm saying, but I can't just, actually hold on to something and say, here it is. Although my DNA tests, CAT scans, all that business is all 100% certified by certified labs. So that's not even a question. But what happens in here is well, here, let me show you. There's certain types of chemistry that can affect the silicon. Well, see this here? See these holes? I don't know if you can see it. See these little holes in here? This is a tendon assembly. I cut it open in a couple different ways so you can see it. And it has a round ball that snaps right in, and this is the strap that comes back, and this pulls you around, these tendon balls. Well, this one here, you see all these little holes in here? See all those little perforated holes? Those holes have been eaten out by I believe this was in an acid, which was fluorine or fluoride or something like that. Not fluoride, but it's one of those. But anyway, this is what happens when they're not in that condition. This is a tendon assembly. See the round ball at the end? Same as the other one I just showed you. And that locks in. And then there's another set of balls that run around the same area. And this was on a strap that did this, you see? And that, they slide back and forth. And that went down to another ball just like this. All right, and this is where it anchors on the mat of the tendon. Hope you can see this. All right, and well, let me show you one of these mats so you'll understand where these balls invest. And these balls have straps on them. See, that's the strap sort of thing that comes back from the ball. And it anchors it through like a Chinese finger trap. I'll show you that. All right, you can see this. That's the ball that we're talking about. That's like this little ball right here, this round ball. And that's supposed to be down here in the flesh. They pull out and they, then it's painful, very painful. And anyway, from that ball, there's a little strap that runs back to these mats. These mats are the walls that they made down in Peru. And that's where the bumps are on the walls. They just snap those off. They cut those when they were wet. After the flood, the giants, these are all from giants creatures. I mean, that's all I can tell you. And after the flood, they were driving around on these creatures, cutting pieces of them and building walls out of them. That's what I saw and what you can see, and see if you see the same thing I see. All right, I got a couple of shots to show you here. You can see, obviously, you got tire tracks, and they sink only so far, and these are like tank treads that keep it supported so that they can drive up here, and they were cutting slabs off of this wet. It's obviously wet. This thing sunk in it. They were cutting slabs when it was wet. They took those slabs and they built the walls and all those things down in Peru. And I'll show you that. All right, so here you have, this is the tendons. This is tendon. All right, and these, it's CaCO3, it's calcium carbonates it's called porphyritic basalts. And it has all kinds of little fibers in here. And I'll show you the fibers that are in these things. They didn't understand this. They think it's extruded or so, whatever they think. But these were wet at one time because they were drying out after the flood from giant creatures. They drove on it, whoever it was, with these high advanced technical vehicles. They cut these slabs and then they built those walls in the background. And that, I can't see how anybody could argue with that. These things, how did they ever fit these together? So look at the fancy way they did it. Well, they did it because they were chunks of wet flesh. They put them together like putty or like butter. That's all I can say. And you can see it. And who can argue with this? Who can argue with that? And you can see the cuts in them and everything. Look at it. Cut. They took them off and built stuff. And I can tell you for a fact right now, you see this material? These little white things are what's called mineralization, which is the calcium bits and pieces of structural component, which is in what is also known as the abrupt transition, which goes from tendon, which is almost completely white, into almost completely red muscle mass, which is still has connective tissues within it, of course, to hold it. But mostly it goes from completely white to this sort of stuff into a completely red, well, mostly red fibrous mass. And that's the nature of muscles. And that's what they were mining, is flesh. And this is another tendon. You see that? That's all tendons in your body, and every tendon has a layer around it. It's called a synovial sheath. And it's made out of this reddish little kaolin clays. And these little slippery clays, just like you ever slip on real fine slippery clay, they call it slip clay. And they make fine china out of it. And that's this kind of stuff. And it's the same thing that's in skin. And that's kaolin clays. And that's why you see them here, just in a very, very, very fine layer. But that also separates the tendons from each other. That's also within the fascia of your body. Fascia is a coating of every single thing in your body to separate it from everything else. You're just not one big bag of gush. You got a liver, you got a kidney, you got a heart, you got a this, you got a that. Even every cell is covered with fascia, because it cannot be part of any other cell. So they all have like this coating around them, like a plastic bag around everything in your body. And then when you die, it continues to separate those things because it is now still in a watery condition, a wet condition, because of the flood. So now here it is, your a body of any creature is in this wet condition. It's pH 7 point whatever it is, very close to 7.23, whatever in that area, same as a human body. In that condition, the blood and all that stuff doesn't even know you're dead. It's good. It says, okay, just keep running that stuff around me, because that's all it does. Is it runs through your body. It's like water pouring through your body all the time, but it's blood. So now, as that stuff continues to just flush in and out of your body, because you're just in a soup, you're just floating around in a soup, and it's happened. Okay, go ahead. Say, what happened to this amount of blood? Well, I don't know. It's gone. Where'd it go? I don't know. It left out of here. Well, where did it go? It went into the solution of the ocean, obviously, and eventually all of these what's called volatile organic compounds that are in your body that are explode when you die in a normal condition out on a desert or something. Your body, the chemicals in your body literally explode. Now, when you soak forever, and they call it waterlogged, all that stuff leaves. So what you have left is semi-stabilized organic matter. So your tissues, your organs, everything in there says, hey, I got to go bond with something here. I lost all the guys that came, delivered me the food and all that stuff. They're gone. What happened? Well, they went into the water. So now it says, I need something to stop me from just going off on my own. So it's looking for somebody to get stable with. Well, water is continuously pumping these chemicals in and out of this creature that's dead now. So eventually it'll find somebody that wants to mate up with. Every molecule in your body will find a semi-stable partner or a completely stable partner. And some of them will eventually become completely stable. And as soon as they dry out in the oxygen comes in, and it dries everything out. So you know how things dry out when they just sit in the air. And that's just a natural event. And they get softer and softer. They get harder and harder and harder as they dry. And that is the nature of limestone and tendons and meat and everything, because the clay is nothing more than meat. It was nothing more than meat before it started to dry out. And that's why, let me show you some of the things that Michael sent me, and they are meat and now drying. And his conditions are much more dry than the conditions I'm used to, because I work with primarily wet forever fossils. And let me show you how much wet forever will preserve. All right, this is a lung. Now, when I talk about colors, and by the way, this is my good friend Gary Evans, another one of the mud fossil researchers over in England. He found this in a mud flat, and a saltwater mud flat. And when you find them in that condition, they could literally last for almost forever. Now, he took this out, and it broke open a day or so after he had it, and this is what was in the center. That black is the blood that is the FeO2 blood, ferrous oxide O2 blood, which means that it's already used its oxygen. It's coming back to get more oxygen in the vessels of the blood. This is the oxygenated red blood, which has already passed through and absorbed the oxygen. It's come out to FeO3 now. And this will go through the body, and as it goes through the body, through the arterial network, which has no restrictions. So the arteries, zip, the blood just flows down, and it's branched, it goes everywhere. And then the veins are what you'd consider a black hole. You see inside the veins, look, you see the black? They suck the blood back up out of all the tissues all over your body, and they will not let it go backwards. There's little valves in them. So the black blood we find in all the mud fossils preserves in its tubing, because it can't leak. But the arterial blood leaks back out because it has no restrictions. And I'm going to show you a finger here that demonstrates this quite well. Hold on one second. There we go. Hold on. All right, you see this? This is a finger. And you see the colors and everything. Whenever you see the colors, you know that it was preserved in blood. When you have a lot of colors, transition molecules, that's blood. That's blood. Now, you see what came out of here? That's blood. That's the artery. Arteries are, you have a bunch of arteries in your fingers, and you have one here, and one up here to arteries, and you have vein, vein, vein. And then, of course, vein coming back, artery coming back. When you die, all the blood, if you die in a certain way, the blood will be forced to find gravity, will blow it right out of these arterioles, and this is where it blew out. When it does that, you're going to see garnets, and garnets are the blood when it seeps out. Garnets are bodily fluids. Right? Garniferous material is bodily fluids. That's all garniferous, and it's all bodily fluids. And I have other ones that demonstrate this quite well. Here's one here. All right, you look at this. You see that? This is a toe, by the way. You see, I hope, again, I never can tell what people can see on these things. But that's the red, and that's the black. Artery vein. Artery blew out. You see all the colors. You see gold here? I believe that's electrum. Electrum is all of the platinum metal, heavy metals. And the reason that this is collected here is because this guy died with his standing up, and all of the stuff drained down, and it tried to force its way out. And as it was leaving, it got like filtered, the blood. And then all of the blood ran out his toe, and that's all over the place here. And that, oops, all over the place here. And that is the garniferous stuff. So these are the kind of things you can look for: is transition metals, the colors, the red, the black. All the colors are the transition metals, and that's that's blood. That's always blood. You see this, and it depends on what kind of conditions it is, Michael. Because my area here is all wet, forever been wet. And almost everything I have here I found on my own property. Well, I mean, everything I did find on my own property, except for the stuff that people send in to me, which is like Gary sent me this one. And I have people sending me stuff from everywhere. Very, very, very effective way to do this. Otherwise, just hide in the woods. I can look at this stuff all day, big deal. But if somebody says, "Oh, what about this? What about that?" Well, we get somewhere, just like you're doing. So, we'll get to the end of this. But this all is from life. Every single rock on this planet, all the way deep as I can see, is from life, except for volcanoes. Volcanoes and the lava is a biological earthly process that sends food, literally food, back up to the surface to feed the plant life. The plant life feeds the animal life. The animal life is the planet. I mean, it's all biology, 100%. And Russia seems to be allowed to do research without malice, like in the United States. They drilled, and this is like 30 years ago, they drilled the Kola, it's K-O-L-A borehole. And it's the deepest hole on Earth at that time, and I think it may still be. So it was like 8 kilometers deep. It was very, very, very deep. And what they found at the bottom is totally different than they're even teaching today. There's no crust, there's no mantle, there's none of that stuff. It's all broken up rock. There's tons of water way, 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 way deep because it's digestion. It's completely broken up, fractured up, little bits and pieces of this rock, and all of the hydrocarbons have been stripped out. And whatever's left is minerals, and they found that there's a layer in the earth that sends that over to the volcanoes, and they pump it back up to the top to feed. It's a biological process. The earth is alive. So there's a lot to this. It's not just a bunch of monkey bones. I'm talking about some serious stuff that has deep, deep, deep meaning. So, working together with people like you, Michael, you're a world-class guy. You have a huge following, and this has to be known. And thank God for you, my friend, and I hope you do help and get this out the best you can, because, humanity is really being disserved at this moment. So, I don't want to get too political about this, but, this is my whole motivation for doing what I'm doing. That's why I'm helping people and trying to get this stuff out. So you work with me, I'll work with you. Let me show you what this lung looked like moments, literally, after it came out of the ground. Hold on a second. Okay, this is right immediately when it came out of the ground. See, it's all muddy looking because it was deep in the mud. And it's forever, literally forever. If they stay forever, the molecules in there are comfortable in that environment. If the pH is correct, and it's water, and it's aqueous, and it never dries out, everything will stay so unbelievably well. It's incredible, because inside that covering, which is the fascia, they call, in the lung they call it pleura, which is no more than a thick coating of fascia, and inside is the lung. All right, so I think I went over this one. I think that is from a tendon ball, the external part. Okay, this picture, this is, I believe, was a lung, and all crushed down from a lung. And these chunks are the little bits and pieces of the lungs, and all the different colors are your lung tissues, I believe, and from my studies here, have different type of chemistry in different types of the pockets of the lungs. They're not all the same. Because you see all these different colors? That is the different colors of transition metals. Transition metals are attracted by different type of chemistry in the tissues of your body. And like muscle is red, and tendons are white, and the liver is like a real dark clay look. Anyway, let me show you what happens to lungs. I have some here that here's one that was cut open, and I could show you a similar situation. The chemistry is the same. You see these little chunks and all those little different colors and everything? That's inside of a lung. And I think that instead of all of these little pockets being the same, I think they're all different. And that one of them will mine a different type of chemistry out of the... I just don't know. But why are they all different colors? Why aren't they all red? Why aren't they all black? Why aren't they all blue? But they're all different colors. So, just like this, green, red, orange, yellows, grays, black. That is the nature of transition metals, and they are the things that keep you alive and the things that do the work inside your body, transition metals. I go on about this because that's your health right there, and I have I'm doing a study on that right now. Now, what else we got, Michael? You got red and the black, it's all mud fossil stuff, but you have to get it real clean to be able to see it right. What you're going to see is it goes from red to yellow to black. Well, I got some over here to show you that. Hold on, let me find one. Alright, you see on the left there, that's where the blood would have come down, and then as it moves over, it turns black. And by the time it gets over to that side, it's black, very black. And then it gets sucked back up. You see all the little tiny holes in there? That's just the way your body works. It pushes the blood through all that, and they suck up. See, the red started here, and then it moved over, got yellower, and then brown, and then it turns black. And then sometimes you have lungs that are like this. They're just little different colors. You see, that's a lung. And then you get all these different looking colors in there. And that's the chemistry of how your body does things. And this was the other one that shows how that's in. See all the different colors? And then sometimes they'll completely bleed out. Hold on. Like, oops, no, I grabbed the wrong one. But it's like this. Only all of these, it would go down to nothing where there's just nothing but holes in it. But it's this basic shape. This is the shape of a lung. And all those little holes, it depends on the kind of conditions that it gets preserved in, whether it's in mud, or whether it's in a clear liquid that it's preserved in, or whether it was in blood. Now, blood creates the opals. The opals are the cool ones, and that's because it has all the transition metals, and that's why you have all the colors. What else we got here, Michael? Whoops. Alright, before I go... That's wrong. I'm sorry. Hold on. Alright, I'll probably wrap it up today for this, but I'm glad to do this for you, Michael. Anything you have, send and I'll do what I can for you. Very important stuff we're doing here. Now, you see all these different little layers? You see the red? You see that look like sandstone at the top? That is a muscle assembly. And these things interweave. This is not anything to do with sedimentation. Now, additionally, the layers of red are what they call leucine-rich proteins, and and the muscles, everything here, all this stuff has to move and be flexible in your body. It's not just one big block, a chunk of something. Everything is moving against everything else. Everything has to be lubricated from everything else. That's the synovial sheaths. That's the leucine-rich proteins, which are these red things. Now, so anyway, that's a muscle. That's a muscle assembly. Oh, and you can see, you see it? That's how it is. Now, the bottom here is another one of these slurpy layers, which they call the leucine-rich proteins. You see the red all over here? Well, you can't see that. Hold on. All right, you see the red all over here? Now, when you put water on things, it immediately hydrates them. Now, these are so dry that they don't hydrate quickly, but water comes, is necessary to hydrate these things so you can see the colors. You see this? This is a tendon assembly right here. And watch that, it'll turn red because that's still going to be able to get hydrated but that's the blood. Now, what happened here was their tendon strap came up, and that's where the ball was. I snapped it off. That was the actual tendon strap that came and held that ball in there, like the muscle tissue that I showed you before where the ball was pulled out. Exact same thing. And if you look at the end here, you see that? That's the vein, and that's the artery. The arteries blow out because I told you they're unrestricted. There's no valves in the arteries. The artery blood comes down. That's why you poke or break an artery, it squirts all over the place. You can't stop it. You have to tie it off. A vein, you cut into a vein, it's a little different. It won't leak back into your body. So anyway, and then this is the tissue, and then of course that's the fabric stuff, the same stuff, the fascia that I talk about. And all these little holes were all little tendon investments, you see? Same stuff that I showed you here. That would have been a tendon ball. Tendon balls. They call these tuberosities. And this was a fingertip. That was a fingertip. This is a fingertip that came through space. You see that? All the muscle is gone from it. All of the meat is eroded from this. All that's left here is the tendinous material, the really hard stuff. Remember I say there's a vein and an artery? The vein side didn't blow out, it just got black. The arterial side exploded because it boiled and blew out from the heat. The same way Comet 67P does its coma and shooting out all of its vapors from the from the arterial holes. So this whole side blew off. And this right here is a tendon enthesis point, and that is the neck of the enthesis, and it ran back here. You see that? That is the straps that run back from the tendons back up into the hand. That was a fingertip. I'm not kidding you. It was a fingertip. So is this one. Whoops. Oh. This one was CAT scan, DNA tested, all that. This is and that's where the tendon invests on the side. You see the different colors and the black and everything. This is the red side, the arterial side. And those little anchors there, that's where the tendons grab in, and they do all that kind of stuff. So I suppose that's about it for today, Michael. But this is all legitimate stuff. So when you see these kind of things like this, and you think that's just a rock, it's not. That's been CAT scanned, checked out, DNA tested. Oops, this was the one that's been DNA tested. The last one I just showed you a minute ago, it was CAT scanned, not DNA tested. But this was, and that's the bone silhouette of the distal phalanges. There's a vein and an artery. Arteries blow out. The veins don't. That's a bone, and the reason the bones, you don't see bones in bones, is because they've been transitioned into what they call source rock in the petroleum industry. They turn into hydrocarbons, but you can see all of the absolute total anatomy. That's bone foramens and ligament emplacements, and tendon enthesis, and little tiny tuberosities, and cartilage, and periosteum, and fascia. And you see that? You see that little angular looking thing? That's how the ancient Greeks used to call this tunica. It wraps everything in your body is fascia, and it wraps it just like one of those little crescent rolls. They come around with an angle. and it seals it up, and it wraps the whole bone. And all of your bones are wrapped like that, every one of them. I don't know if you even know that in medicine. These are actual anatomical specimens. There is no better anatomical specimen because the chemistry, the biology is now stone. And when they get separated off like this, even like this, you're going to look at that and say, oh, that's just a rock. No, it isn't. That is a toe. I know. You're going to say, oh, you guys nuts. No, I am not nuts. That is a toe. And you see the red there? Whoops. You see the red? They all, of course, have red and black in them, and there's blacks in here, too. And this over here is this bone right there. That's the last of the bone that was in this thing. And that bone is the little pad on the bottom of a big toe. And you have one on yours too, and it's real hard. And I have other ones that show it much better, and they're much bigger. And I'll show you one right here. And then we'll get out of here. But these kind, you see here, this is probably a good one for you to see. This one up here. All right, this is it's another big toe. And I just showed you that bone piece that was in that metal one. There it is right here. That's what's going to happen to this thing too. It will end up just like that piece of metal I showed you. And the reason for that is that they all want to get down to like just nothing left to them. It's called sublimation. Now you see the little fibers in there, those little fabric fibers? All right, you're going to see that on anything that has fascia in it. Skin. All right. You see this here? This is that gnarly little skin stuff that's in between one toe and the other that you have. That right there is the guy's toenail. That was his toenail. This back here is the vein, and this is the artery side. Here's that tunica. You see it coming up, wrapping straight up here. They all have the tunica that wraps the bones. This is the guy's callus. I'm not kidding you, man. That's the guy's callus. And you see all of the metals coming out of here. I don't know if you'll be able to see those. I doubt if you will. But these are all metals coming out of here. Here's blood. And the reason this side didn't blow out, which is the arterial side, is because of this nasty callus. So what happened was the other side, the artery side, see it, the black side here, exploded out, which it never does. That's almost unheard of, because the other side is the weak side. This is the strong side. See, it blew out here and blew out there. That would never happen unless that's so capped off. That's why. And then, at the end of the tip, there's an apical tuft right under here. You see that really gnarly stuff? Look at the crystals and everything. This is what happens here. Look at the tip. This is where that apical tuft was. And if you could see these are like diamonds. They may even be diamonds. But look at in here. They're all crystals. And this thing will turn to crystal eventually. I don't know if you can see that, but they're all over here. And this will eventually turn crystal, and then it will turn into metal. And that's just sublimation. I don't know how I can explain it. Well, eventually it'll turn like this. Like that, and then all you see is a little bits of blood left, and like this. And then the metals will, if there was a lot of metals in this one, it would actually turn into the metals. But this one didn't have a lot of metals. If it did, it would turn into this. Here's another toe. See, that's the toenail, and there's the red blood underneath the toenail. They all have that. There's the guy's callus. They all have big calluses. And this is starting to come down to the metals, you see? Depends on how the guy died. Where did the blood settle? That is the key. Where did the blood settle? If there was no blood in this, it'd just look like a rock. It would look like a dirty looking rock. But it has all the metals have been collected in here. So there's a lot of things that people just don't understand yet. And I don't understand a lot of things either. I'm just looking for answers too. So I'll do what I can to help you, my friend. Keep them coming.